Hello class, a couple quick updates. So you had modeling 0 and modeling 1. Nice job collectively as a class. So modeling 0, all groups got A's except for I think 1 had A minuses. So I put some of those ones that I liked in the samples and examples in the notes. So I'll show you that, where that is. And then also on modeling 1, A+ for everyone, all groups did the bonus as well. Really nice job. So we'll pull up a few of those and just talk about some comments overall. Okay, so we're in Oaks in your class. Here we are in module 4, assignments. So week 1, there was your modeling 0. I put some answers to this from your classmates. So I selected this time the group of Chloe, Olivia, and Michael, and then the group of Kevin and Jenna. So let's look at first one, Chloe, Olivia, and Michael. This one's nice just to see the answers with the assignment. A couple groups did this, so they hand wrote in between, right in place. Really nice job. Explanations on this. I think this is Chloe's handwriting here. Really nice explanations throughout, so nice job for this team. Oh, solving this with shows the MATLAB code as well. So if you're still trying to work out that LinProg or in LinProg, that's nice to check your classmates' work. And then nice job. This is just such a wonderful, that page with the ways that you can take 0, 1 variables and do so many things, if then, either ors, complements, so many things can be done that way. Of course, it does add a complexity because you leave from linear programming and go to LinProg, but that's the next best thing. And often what you couldn't have solved in LinProg, you now can do. So you're willing to take that hit to be able to model it correctly. Okay, let's go back and see. The other group, this was Kevin and Jenna. I really like that they set theirs up, as did Zach and May always do that as well. So the question and then step by step with the answers. So I don't think there's too much difference between the groups here. Oh yeah, so they explained this, and a couple groups did email me about there are some. It's tough on this particular one from the text that seemed a little confusing the way the subscripts were done, and then when I tried to change an assignment later, maybe make it a bit clearer. And I think y'all worked your way through that. These always funny notes like, what did you forget? Well, got it. So I enjoy just going through and seeing different styles and humor in this. So again, check out your classmates' work if there's any sections that you yourself didn't quite get. You asked your teammates maybe several times and still weren't sure, but often when you see another person's explanation of it, it finally clicks. All right, so then let's go back and check out the modeling assignment 1. So we're back in Oaks again. Your assignments. Now we got week 2. Week 2 has both the original assignment, and now I put this time a group of Ashley, Maddox, and Kristen, and Brianna and Avery. So let's take a look for different reasons. So the only place that some groups struggled a bit was the satisfiability problem, number 1. But really, it's what we've been doing throughout this class. We just don't have an objective function. So you can make the objective function anything you want, actually. So you could set it to all zeros, that F vector that we're plugging in MATLAB, all ones, whatever you want. It doesn't really matter because what you're trying to do is just see whether or not you can get a feasible problem. So either you throw it into MATLAB and it'll come back that this is infeasible, or it'll come back with a solution, and that is one feasible solution. You could do it random restarts if you're trying to find alternate feasible solutions. And again, you don't care about that objective function. So a couple of the groups got closest to explaining that. That's why I put Brianna and Avery and Ashley, Maddox, and Kristen in there. Nice job on very clearly showing the model here with data enter into MATLAB. Yeah, and the outputs, the results, and also the bonus problem. I just want to talk about this one, writing it out by hand and entering that into MATLAB. A couple groups entered it all in. I just want to show that, so you could initialize A as the zeros matrix, right? Whatever the dimensions on this 1, 2, 3, however many rows, was that 7, and however many columns, 21, right? But then some things you see some structure. So why not go in and say that A rows, so parentheses 2, 7, and columns 1, 6, I guess. Right there creates that little sub matrix. So you're telling it to make that I6 matrix. Right? So you can go in and build this sub matrix by sub matrix rather than like sitting there 1, 1, 1, 1, 1. How many do this get? But count them 0, 0, 0. How many are there? Right. So that's tedious. And maybe there's ways where again you see structure. So I see this structure here. I just go in and say A1, comma 1, 6 equals 1, 1, 6. Right. So I'm going to just build this piece by piece. Often in even bigger problems, again, there's industrial software, talk about this in the videos for class, that it's much easier to, it's written very similar to the way you write the constraints. But if you're in a software program like this, where you have to build that A matrix, a lot of times it's just looping through. You see a structure and you're just looping, doing loops, nested loops to fill in the A matrix. Okay, let's go back and check out one more. This is the team of Ashley Maddox and Kristen. Okay, again, satisfiability problem. I'm trying to relate it to things in class. Some groups went really overthought this or Googled it and trying to think of other ways to do this problem. But there are other ways to solve satisfiability. But for us, fitting that, just put it in this framework. This is the easiest way to do it. What I liked about this one, oh right. So this is where I think in the problem number 2, I was saying in the instructions use LinProg, and they're showing that hey, you get these are fractional, they're small values, so rounding is going to be a problem. It's going to change things quite a bit. If you try rounding all different ways, rounding up, so rounding down, other strategies, you'll get several different solutions, and you're not even sure if they're feasible. You check if they're feasible, plug them into the objective function, get an objective function value, and then maybe take among all these various ways of rounding the one that you think has the best objective for those. Does that guarantee it's optimal? No. So then they talk about what they prefer to do is inline prog. And now I think this is probably by default running a material point method. So this is really is 3, right? If we were doing it another type of method. So this is integer. And then they talk about a nice discussion here that this objective value here is higher. We're trying to minimize, so higher than the one that we got with the fractional, but fractional doesn't really make sense in the context of the problem because these are such small numbers. I think on modeling 0 was a similar question. Could you round? Could you do the LinProg and approximate it? Because the numbers were much, much higher, maybe in the orders of magnitude higher, right? So that's usually acceptable when they're so small. It's not a good thing. Okay, and then the last one, number 3, the police shift scheduling. And yeah, the hint is what most people talk about. It took a while to figure that out, but and that's often when the light bulb clicks. You've done enough modeling, it's hard to do that live on the test, but seeing that there are some tricks to modeling these. Yeah, and again, here's that big A matrix, however you enter it, but there's similar ways. Right, so excellent job on that. Hopefully having fun these last couple of weeks of modeling, because it's seeing the practicality of it. And then we get into the theory in chapter 5, which is beautiful. But one more week of modeling, so have fun with modeling too. I think that's a really fun one. And again, make sure if you're in the team, that you're trying to ask a million questions and understand every part of it. And we have some new super teams, so good luck with those. Yes, go get your capes.